Greetings. In this one, let's talk about this field f sub 8, and the um, uh, characterization thing we can take for it is the fact that f sub 8 has 8 elements, so the order of it is 8. Unlike in, for example, the case of Z5, f8 is not Z. Z8 cannot be a field of order 8 like a general f8 is. So Z5 with elements ranging from 0 until 4 as integers is actually is a field of order 5. It works out. The reason is that for every x in Z5 there exists a y in Z5 such that xy is 1. That means every element has a sort of multiplicative inverse. So if you take any number from this range, you can find another number in this same range that if you multiply it by and then take the remainder after division by this number 5, it gives 1. But it doesn't happen for f8 in the case of z8. So how do we list the elements of f8? Well, here we can get to a sort of generalizable situation, but let's first take it concretely. So our question is, what are the elements of f8? And namely, we know f8 has order 8, as we mentioned, and that is a power over prime. And this is a very powerful observation because that helps us here. If you have a power over prime like this, we can list it as basically elements are polynomials until the degree of this number minus 1. And so what we get if with f8, we know 2 is a prime, 3 is a prime as well, but that's not really important. The thing is the base here is a prime, and then we take it to an integer, so we see this as a prime. So 2 is a prime, or what we can say is 8 is a power over prime. Namely, it is the third power of the prime 2. And how do we list elements of f8? Well, as I said, they can be listed as polynomials. And in this case, f8 is polynomials with degree of smaller or equal to 2 and coefficients from a field of 2 elements. So generally isomorphic of 2 elements. We can take concretely Z2 later when we write it out. So basically f8 therefore from that will be, let's come back here, will be writable as we have coefficients from f2, and there will be how many coefficients? Well, there will be actually the same number of coefficients as is the power of the prime when we look at the order that's created as a power of the prime. So it's three coefficients because we range from degree 0 until 3 minus 2 until the degree 2 because of this 3 here. So what do we get is c0, that's the first coefficient, plus c1x plus c2x squared. And c0, c1, c2 belong to, let's say, z2, field of order 2, either zeros or ones. So if you want to concretely, explicitly list the elements of f8, instead of this general notation, we can list them. And the way we do it is namely, we just plug in c0, c1, c2, either being zeros or ones for this polynomial of degree up until 2. So that is 1, 0, x squared, x plus x squared, x plus x squared plus 1, 1 plus x, and 1 plus x squared. Let's check that the number is 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So we have 8 elements now. And we can generalize this. But before we do that, let's take another example. And that would be, for example, f32, which is simply a higher power of 2. Namely, that's f of 2 to the 5th power, because 32 is the 5th power of 2. So here we'll proceed very similarly. When we list out the elements, this time, just like before, the power was 3, 2 to the 3rd. So we had 3 coefficients. Here again, we will have c0 until c4. So that's 5 coefficients. and we have them like this. So c2x squared, c3x cubed, c4x to the fourth. So these elements, and of course, again, the coefficients will be, so let's say c0, c1, c2, c3, c4 belong to, again, a field of the same order as was the base number inside the prime power. So when the order is a power over prime, the base in that exponent form is the order of the field from which we take the coefficients. So under generalized circumstances, if we have a field of order p to the n, when that means its order is the positive integer power over prime, so p means prime here, of course. Then if we want to list out the elements, we have fp to the n. If you want to list out the elements as a set, we have c0 x to the 0, x to the 0 plus, and we continue until set to the n, x to the n minus 1. And this is cn minus 1 actually. So c sub n minus 1. Right here, c sub n minus 1, x to the n minus 1. So for the case of when we have f sub 32, again we had to have coefficients until c4 from c0, so 5 coefficients, don't get mistaken, there's the c0 to count as well, and the highest order of x was 4, which is 1 lower than the exponent here. And the field from which we take the coefficients, where c0 until cn minus 1 belong to z of the prime number p. So that's the way it works with these polynomial elements of a finite field whose number of elements is the power of a prime.